An extension of our first kinematics example, we're still using the same displacement function of t squared plus 2t take 3. Average velocity from t equals 1 to t equals 3 seconds. So the average velocity, if we're trying to find that, we want to be able to identify the change in displacement at 3, take the displacement at 1 over 3 take 1. So Year 10 physics formula. So when we're doing that, we can find the results from our previous example. 3 we were at 12, 1 we were at 0. So we get 12 take 0 divided by 2. So our average displacement is going to come out to be 6 meters per second. So just using some year 10 physics concepts. In part B, where you're looking at finding average velocity given by that function, write a similar expression for the average velocity between t equals k plus h. So what we're doing here is the concept of first principles. So we're identifying that to substitute k in for some random value and k plus h, we want h to approach 0. We're finding the instantaneous velocity rather than the average velocity. So an expression, or in this case an equation, for the instantaneous velocity is going to be the limit as h approaches 0. Substituting k plus h in, we would get k plus h squared plus 2 lots of k plus h take 3. Take the function at point k, which is just k squared plus 2k take 3. Remembering to put brackets around that second component, and it's dividing it by h. Again, we're trying to identify where h approaches 0, so the interpretation is when h equals 0, instantaneous velocity is found, as opposed to what we did back up here, an average velocity is found across the 2-second interval. If we use the calculus concept and we let h approach 0, we're finding an instantaneous rate or instantaneous velocity.